Okay, so last section we're going to look at in chapter 9 is 9.4, and it's on conic sections. So conic sections are basically the different ways that you can take a cone, slice it, and look at the cross section. Okay, those are the different shapes we're gonna study. Anybody think they can tell me one of the shapes you could get if you take a cone and slice it, and then look at the end of it? There's four different shapes. One of them's a little different because you actually have to put two cones together and slice it. That one's a little different. But the other ones you can get just by slicing a single cone. Yep.
A right triangle?
So all the shapes you get are going to be curved. Yeah, they're all going to have curves to them. Yep.
Circle.
Yep, a circle. That's definitely one of them you can get if you just take the cone and slice it perpendicular to the base and then look at the end. You would have a circle. That's one way. Yep.
Semicircle.
Just got it straight in half.
I don't know if you can get a semicircle. I'm not sure that's one of the shapes you could get by slicing it. Yeah?
Oval?
Okay, yeah, an ellipse. So we call that one an ellipse. You can kind of see the other ones already, but the parabola and the hyperbola. So the circle is the simplest one if you slice the cone straight across. The ellipse is when you slice the cone at an angle, but you make sure that when you slice it, you're still going through the side of the cone. Okay, that would give you, looks kind of like an oval, we call it an ellipse. A parabola is kind of like an ellipse, but you've sliced it at so much of an angle, now you're going through the base. You're not going through the side. Okay, that gives you a parabola. And the hyperbola, that's the one that you technically got to put two cones together with point to point, and you slice it straight down. Okay, and if you slice it straight down, you get these two curved shapes. And those are called hyperbolas. Okay, so those are the four different conics that you can get. And what we'll do with each one of them, we're going to look at the equation. Like I'll give you the equation, and then I'll ask you to draw it. Or I might draw it and have you tell me the equation. Other things I might give you are like special facts about them. Like I might say, I want you to tell me the equation of an ellipse that has a minor axis this long and a major axis this long, and it's centered at the origin. Right? So I might give you some facts about the shape, and then you got to tell me what the equation would be or sketch it. Okay? Yeah?
So would a hyperbola basically be a reflection over the point where they meet?
Yes, hyperbolas are symmetrical, yeah. All these shapes are symmetrical if you draw the right axis of symmetry. Yeah. Parabolas, circles, and ellipses, yeah. But yeah, hyperbola is the only shape that has two separate pieces to it, and those two pieces are called branches. Okay, we'll talk about that Wednesday. So the circle is the only shape we don't talk a lot about because we've done a little bit with circles. I know I showed you how to sketch circles when we did parametric equations. We are not doing any of these conics with parametric or polar. Right? If you do them with polar, which is what we learned last week, some of it actually becomes simpler, but it's a whole nother lesson to go through them in polar. So we're going to talk about these equations in terms of like y and x, okay, Cartesian coordinates. Okay, so any questions on the four different shapes you can get from the conics? So we're going to start with the parabola. Each conic that we work with, I'm going to start with a definition, and then I've got a program where I can kind of show you in a little more interactive way how that works. So if I was going to define a circle, just because I think this one is easier for everyone to relate to. I would say a circle is a collection of points that are all equidistant from a single point. Okay? So you have a single point, imagine like tying a piece of string to it, and then going around, keeping the string pulled tight. Every point that you draw is the same distance from that point because of the piece of string. So it's a collection of points equidistant from some other point. And in a circle, we call that point the center. parabola, it's a little more complicated definition than a circle. So it's a collection of points, and we are doing 2D. Okay, conic sections are all 2D. That's why it says in the plane, not 3D. So a collection of points in the plane that are equidistant from two things. Okay. Not just one thing like a circle, but from two things. The two things that they're equidistant from is a special point we're going to call F. We don't know this yet, but it stands for focus. And a special line that we're going to call D. And D stands for directrix. Okay. I'm going to write those down. So it's a collection of points that are equidistant from a special point we're going to call F, and a special line we're going to call D. All right. I've got a picture of that, so we'll take a look at the picture. And what the picture is going to allow me to do is take a point, put it on a parabola, and then I can drag it around on the parabola. As I drag it, I'm going to measure the distance to a special point and to a special line, and you're going to see that those two distances always come out the same. I have to do this over by the desk because it won't let me drag it from the smartboard. But this, let me see if I can rename that F. I don't know if I can. Maybe. Okay, yeah, so F, that's the special point that is going to be called the focus. And that blue line at the top, I have to name it with two letters because that's how this program works. Line DE. I'm going to take point B. Let me see if I can drag it. I'm going to take point B and I'm going to drag it along the parabola. Okay? And I want you to watch what happens as you measure the distance from that point. Well, from that point to F, and then from that point straight up to C. Okay, so let me do that. And notice as I drag it, the distance from point B to F, and from point B straight up to that line at the top, and all those two lengths are always the same. Okay, it's measuring them right up here and right up there, those two. The other way. Okay, that's the shortest distance right there that you'll ever get. That's 3 units. And then as you start going the other way, you can see from B to F, which is the distance from the point to the focus, and from B to C, that's the point to the line. Those two numbers are always exactly the same number. Okay. So that's the definition of a parabola. Any question about which two distances always stay the same? Okay. As I said earlier, F, that stands for focus, and D stands for directrix. Okay, when we go through conics, there's a lot of vocabulary, a lot of different terms. And the reason they call that point the focus is if you think about it in terms of, pretend that that's part of a parabola. A lot of mirrors will have a shape like that. And if you make a shape like that, the mirror will focus all the light that comes into it at a single point. Right? So like a car headlight. A lot of times when you're looking at the light coming from a car headlight, you're not looking at the light bulb, you're looking at the light bulb reflected off the back of the headlight, which is like a mirror. So usually they put the bulb like right there, and that special point that they put the bulb at is the focus of the mirror for the car headlight. And by putting the bulb right there, what happens is, no matter, and there's like usually a little shield in front of the bulb there, so you don't actually see any light directly from the bulb. But no matter how the light bounces off the back of that headlight, it always comes out perfectly parallel. That's how a parabolic reflector works. No matter what angle the light bounces off the mirror, it always comes out perfectly straight. And that's what you want for a headlight. You want the light to come out straight. You wouldn't want it bouncing like up in the air. See the same kind of thing with like a satellite dish? Sometimes there's like a little, I don't know what they call it, but there's a little thing like in the center of the satellite dish where all the signal comes, it's kind of the reverse of a headlight. All the signals are bouncing, they're bouncing in, and they're all focused right towards that little spot on the satellite dish. And then usually it's connected and goes into your house. So a parabolic shape is used for lots of different things. Okay. This is describing a parabola, just more as an equation. D stands for the distance here, lowercase d. So the distance between the focus and a point, and between the point and the directrix, is always the same. Okay, and I didn't draw figure 3. It's in your book, but I used that other figure right here. That's basically figure 3 in your book. All right, so now I'm going to go through all the vocabulary, okay, the different terms for things. So if you draw a line through your focus and perpendicular to the directrix, that is called the axis of symmetry. So if you had a parabola like that, by the way, there's 4 different kinds of parabolas. They can open up, down, left, or right. Those are the 4 ways they can face. This particular one opens up. If that's your focus, if you draw a line through that and make sure it's perpendicular to your directrix. Directrix would be somewhere down here. Okay, the parabola always bends away from the directrix. Okay, the directrix is just an imaginary line that it bends away from. So if I draw a line like that, I tried to make it perpendicular to the directrix, which is the dotted line, and I made it go right through the focus. That is the axis of symmetry. Okay, the point where, right there that I just put in green, the point where the axis of symmetry crosses the parabola, that is called the vertex. And I think we've talked about that term before. Now, the parabola, you can measure the width of the parabola, but the width is always changing. It depends where you measure the width. Well, if you measure the width through the focus, okay, they call that the lattice distance or lattice rectum distance. I don't know why. That's what they use. We don't focus on finding that a lot. As far as applications, we don't use this lattice distance very much. But if they ever ask you to find it, it's the width of the parabola through the focus. Now, I said that there are 4 different ways a parabola can face, which means there's 4 different ways you can manipulate the equation, depending if you want it to open up, down, left, or right. So we're going to start. Let's see. I think I'm going to go through all of that. Okay, we're not going to go through the complete proof of the equation, but I will show you. We're going to look at a parabola opening to the right. That's what this one is. Okay, what I'm showing in the picture is the distance between this point and the focus, and that point in the directrix is exactly the same. That's why I put those little tick marks there. The proof of the equation involves making a right triangle and doing a little bit of trig with that to figure it out. But we're not going to go through the proof. What we need to know for the equation of a parabola is this one. So this is the equation of a parabola where the vertex is at the origin and it opens to the right. Whether you want it to open down, left, or up, just a couple small changes you need to make for that to happen. The equation is y squared equals 4ax. Not normally how we write the equation of a parabola, but it is how we want to write it when we're working with it in this section. You always want whatever you put in front of x to be 4 times something, because this thing that's right there tells you exactly how to find your focus. So for example, I had something like y squared equals 12x, and I said to you, where is the focus of that parabola? Well, you'd want to rewrite it like this. Write it as 4 times something, x. This tells me where my focus is. In this case, the focus would be 3, 0. It would be 3 units to the right. But unless you write it with a 4 in front, then you don't see the 3. Okay. We'll do a little bit more of that. Now, I'm not going to say too much more about the equation, but I'm hoping once I show you the one that opens left, you can figure out what's happening to make it open left. Let's go. All right, so how do we graph a parabola? Well, we need probably about 3 points. Okay, one point that's important to find is the vertex, because that tells you either the minimum or the maximum, if it's opening up or down, or how far left or right it goes. Okay, so you always want to find the vertex. The directrix, well, it's not really helpful for graphing it, but if they ask you to find it, then you have to find it. The directrix is just an imaginary line that it bends away from. Okay, it's not actually part of the parabola itself. The focus, that is handy to find because that's what the parabola is going to wrap around. Okay. Whenever you have a focus, the parabola always wraps around it. So what I usually do is if I know where the focus is, a lot of times I'll find a point like above the focus, below the focus, and then I'll find the vertex. And those 3 points, it's usually good enough to make a sketch. Now, in this case, it's above and below the focus that I would find points. But if my parabola looks like that, I would find a point to the left and to the right, and then the vertex. And those 3 points would be enough to make a good sketch. That's it, what I just showed you. Okay, so for now, all the ones we're going to do are going to open to the right. Okay, I'll let you know when we do something that's different and opening to the left. Okay. So this one says to find an equation of a parabola that has its vertex at the origin. All of them are going to have the vertex at the origin for now. Okay. Later today we will be doing them shifted up, down, left, or right. So this has the vertex at the origin and a focus at 3, 0. And I'm telling you the equation you need to use. Y squared equals 4ax. Okay, so what I like to do first is off to the side, I need to somehow identify A. From the information that I gave you here, they've given you they've given you what you need to figure out A in this case. What's A in that problem? Yeah. 3. And how do you know that?
Because it's in the focus.
Yeah. A, for this particular equation, y squared equals 4ax, is always the first number of the focus. A is 3. So once we figure out what A is, all we have to do is fill it in. And when we fill it in, we can simplify it. Okay? So we can multiply that out. So there is the equation of the parabola, centered, well not centered, with the vertex at the origin, and the focus is 3, 0. Any question on how we got y squared equals 12x? All right, now let's graph it. Well, one point we already know is the vertex. It's at the origin. And what would be another good number that I could plug in for x and then solve for y? I'd like one that I can get a nice answer to without a calculator. Yeah?
Square root of b.
That'd be tough to plug in square root of 3 for x. We wouldn't be able to do that in our head very easily. Yeah?
12.
12. That would be a good one. The only problem with it is I don't have enough room to go to 12, but 12 is definitely a good number you could plug in for x if I had enough space. Anybody think about another number I could plug in for x? Get a nice answer? Yeah? 3. Yeah, if I plug in 3. So just make a table off to the side. So when we plug in 3, 12 times 3 is 36. And then I need to take the square root of 36, which is 6 or -6. So this clearly is not a function. Right? When you plug in one x value, you get 2 y values. So it fails the vertical line test. So 3, 6, 3, -6. Now you don't have to plug in 3. You can plug in any number you want. Has to be bigger than 0. But you can plug in any number you want. You're just going to need a calculator if you get into decimals. All right, and just sketch your parabola. Kind of like that. That's it. Okay. Any question on that? Now, where was the focus in that problem? Yep. 3, 0. That's not actually part of the parabola. It's an imaginary point that it wraps around. Okay. Right there. What kind of line would the directrix be in this case? A horizontal line or a vertical line? Yeah, vertical. So it's going to be x equals. And can anybody tell me what the equation of the directrix would be? You have to put it in a certain spot so that it satisfies the definition of a parabola. If you don't put it in the right spot, then, well, it wouldn't satisfy the definition, yeah?
X equals -3.
Yep, it would have to be x equals -3. It would have to be right there. And the reason we know that it's there is because if you take any point on the parabola, the distance from that point to the focus and that point to the directrix has to be the same. That's the definition. Well, we already know that the distance from that point to the focus is 3 units. You can just count it. So the distance to the directrix also has to be 3 units from this point right here. The only way this point can be 3 units away from a line is if you put a vertical line right there. So that's something else I could ask you, like what would be the equation of the directrix for this situation? Let's look at this one. This one's a little bit different. This time they're giving you the equation, and they want you to tell me all about the parabola. Okay? When I ask you about a parabola, there's generally 4 things I want you to tell me. Tell me the vertex, the focus, which way does it open, and the equation of the directrix. Okay, so for now, where did I say the vertex was always going to be? Yeah? Yeah, it's going to be at the origin. You'll know when it's not at the origin because the equation, well, it starts to look different. It has a little bit more complexity to it. Okay. That format is always at the origin. Okay. In order to figure out the focus, I would rewrite that equation so that we can figure out A. A is the thing you always have to figure out in a parabola. How can I rewrite that equation so it makes A very obvious? You have to rewrite it, and there has to be a certain number on the right-hand side when you rewrite it. Anybody think they know? Yeah? Okay, so what would be your equation?
4 times 2.
So yeah, y squared equals, go ahead.
4 times 2 times x.
Yep, 4 times 2 times x. You always have to write it as 4 something and then a letter. Notice I didn't always say the letter has to be x, but in this case it does. 4 times 2x. Okay. So that 2, okay, that's my A value. Okay, so what A really tells you is it tells you how far away the focus is from the vertex. Now technically you have 4 options. If you're at the origin and your focus is 2 units away, it could be up 2 units, down 2, left 2, or right 2. What we're going to be looking at is in a minute is how do you know which way the parabola opens. Once you know that, you know if it's up, down, left, or right for the focus. But for now, I said the parabola is always going to open which way? Until I tell you otherwise. It's always going to open to the right. So if your parabola opens to the right, it has to wrap around the focus. Well, whether you go 2 units up, down, left, or right, there's only one way that would make sense for the parabola to wrap around it. Is the focus 2 units up, down, left, or right of the vertex? Yeah? It's 2 units to the right. Yep. Okay, and we just kind of answered the next question. The parabola opens to the right. Yep. Have a great day. And what about my directrix? Here's my focus. What's going to be the equation of the directrix? Yeah?
X equals
Yep, it's a vertical line, and the parabola has to bend away from it. If you drew a horizontal line, it would hit the parabola. That wouldn't work. So it has to be vertical, and it has to be symmetrically placed on the other side of the vertex. So x equals -2. And that's the 4 things that I want you to describe when I ask you to describe a parabola. Any questions how we found any of those? Okay. So let's look at this one. Is this the same type of equation as the last one? What do you think? Does it follow the same exact format? Yeah?
Yes, it does. Wait. Oh, that one, no.
No, what's different about it?
It has a negative and there will be imaginary solutions. No.
We're always going to have real solutions. Yeah, we're not going to go into imaginaries with this. So there are 2 things that are different about this equation than the last one. What's one thing that's different? Yeah?
The x and y are swapped.
The x and y are swapped. That's going to do something. And there's one other thing that's different. Yeah?
There's a negative sign.
There's a negative sign. Where the x and the y are, and whether or not there's a negative sign, that's what controls whether it opens up, down, left, or right. So let's look at that. So that's the basic equation we've been dealing with so far. Okay, here's another one. Okay, here's another one. And the last one. Those are the 4 different equations for a parabola. Each one of them's up, down, left, and the other one is right. This one we just did. Y squared equals 4ax. That was this type. It opened to the right. What do you think, or which direction do you think y squared equals -4ax is going to open? Yeah?
Left.
That will open to the left. So look at those 2 and see if we can figure out what kind of a pattern. Well, when the 4 is a positive, it'll, yeah.
It will open up.
Well,
For the next one.
so you look at the positive 4 and you look at the letter that's next to it. The fact that this is a positive 4 could mean one of 2 things. It opens up or it opens right. But because this is an x, that tells you the direction that it opens. Okay? Think of x as the horizontal axis. That means it opens horizontally. Okay? So look at those 2 numbers. It opens horizontally because that's an x, so it either opens to the right or to the left. But it's a negative, so it opens left. Let's look at these 2. It's a y. That means it's going to open in the vertical direction. The 2 directions you can open vertically are up and down. Because that's a positive 4, which way do you think it opens? Yep. It opens up. Okay. This tells me it opens in the vertical direction because it's a y. But that's a -4. So that means it opens down. Now, all those equations, none of them are shifting the parabola. Origin, 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 origin. They're all at the origin. Shifting it is very simple. But for now, we're just going to focus on keeping it at the origin. But now we know all the different ways that it could open. Okay, so let's look at this one. First of all, if it's not written in the proper format, I fix it so it is. This one's not too bad. It would be like even worse if it was written like this. Okay. that's fine if you want to type it in on a calculator. Because when you type it in on a calculator, you need to get y by itself. That's not good for typing it in on a calculator, because y is not by itself. But to analyze it, we don't want y by itself. We want it to look more like this. X squared equals something. But let's fix it so the right-hand side looks more like one of the formats I just wrote down. How can I rewrite this right-hand side? Yep.
Negative 4 times 3 times y.
Negative 4 times 3 times y. And we do that because now we know A. Again, think of A as a distance. It's the distance between the vertex and the focus. So A in this case is 3. Let's put that off to the side. So now we know that the focus is 3 units away. We got to figure out if it's up, down, left, or right. To figure that out, figure out which way the parabola opens. Which way is this parabola going to open? Look at the letter, look at the number, and that tells you. Yep.
Down.
Down. Yep. This parabola opens down. Where, until I say otherwise, where is the vertex? Yep.
0, 0.
0, 0. That's always the second thing you want to figure out. And now the focus is 3 units away from the vertex. And remember, it opens down, so the parabola has to wrap around it. So what would be the coordinates of the focus? Yeah?
0,
0, negative 3. If you did anything else, it wouldn't wrap around it. Like if you went up or to the right, to the left, wouldn't make sense. It's got to be down. And the equation of my directrix. So remember, it's an imaginary line, equidistant between there and there, and there and there. First of all, we got to know what kind of line it is. It's either horizontal or vertical, and then we need a number. Yeah? Y equals 3. There we go. Okay, so they said discuss it. We've done that, and they gave us a grid, so they want us to graph it. So remember, directrix, not actually part of the parabola. Just an imaginary line it bends away from. Focus, not part of the parabola either. Just an imaginary point that it bends around. Okay. Now, let's actually sketch it. So vertex is 0, 0. What would be a good number that I could plug in for y? I know it's a little weird, we don't normally do it that way, but we're going to plug in for y and solve for x. I need a good number I could plug in. I'd like to be able to do it without a calculator if possible. Yep. Negative 3. Yep. Negative 3 is a perfect number to plug in. If you plug in negative 3, you're going to get x squared equals 36. And to solve for x, we take the square root. And what's the square root of 36? Yep.
Plus or minus 6.
Plus or minus 6. No problem that you get 2 different answers for x. That's fine. This is a function. It will pass the vertical line test. Okay, so let's graph 6, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. And I'll do that in green. So green are all the points that I'm actually going to draw through. And then negative 6, negative 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So there's a sketch of your parabola. So it's not really too hard once you know what you're looking for. But figuring out what A is and figuring out the direction that it opens, those are those are the most important things you need to be able to figure out. If you can't get A, then you're stuck. Let's try this one. This time, I'm going to give you some information about the parabola, and I want you to give me the equation. So it says find an equation that has a focus 4 units up and a directrix y equals -4. First thing you want to figure out is which one of the 4 equations you need to use. Is it x squared equals 4ay? Is it x squared equals -4ay? So we're going to figure that out. Okay, so focus is right there. If all I told you was the focus, that's not enough information. Okay. You could have a parabola open up, down, left, or right and wrap around that focus. Okay. But they tell me the directrix. Y equals -4. My parabola has to bend away from that line, just like it does in that picture. It's got to bend away from it. So which way does the parabola have to open? If it's going to bend away from that line and wrap around the focus. Yeah. It has to open up. Okay, they didn't ask you that. You didn't have to say it, but that's going to help you to figure out your equation. What goes on the right-hand side when it opens up? It definitely has an A. I know that. But I'm looking for the number and the letter. Yeah? 4 makes it open in the positive direction. And we want it opening in the Y, 4AY. So now, once you know that, what has to go on the left? Yep. It has to be the other letter squared. This is the only conic section we study where one of the letters is squared and the other letter is not. That makes it a parabola. Okay, so now we've got our equation. Now we just need to figure out, thank you, what A is. Okay, so remember A. I should probably write this down. I think I write this down later on. A is the distance between the focus and vertex. That's what A is. Now, they didn't give us the vertex in that picture, but it has to be halfway between the two that I just drew. So where does that mean your vertex is going to have to be in this picture?
The origin.
Has to be at the origin. The vertex has to be equidistant between the focus and the directrix because it is a point on the parabola. Has to be. Okay, so we got our vertex. Now, A is the distance between the focus and the vertex. Here's your focus. Here's your vertex. What's the distance between those 2 points? Yeah, 4. Okay. So this distance is 4 units from there to there. That's A. So now fill that in. And that will be the equation of the parabola that meets those conditions. And when you fill it in, it's fine to do it out. So it's x squared equals 16y. Hey, any question on the equation? And now just to finish off my sketch, what would be a good number that I could fill in for y to make it easy to solve for x? Yeah, 1. Yeah. If you plug in 1 for y, you get x squared equals 16 which means x equals, Nick, what would x equal? 4. Negative 4. Yep. Now graph those 2 points. 4, 1, negative 4, 1. So 1, 2, 3, 4, 1, 1, 2, 3, 4, negative 4, 1. It's pretty shallow. That's not really a lot of points, so I'm not going to be able to get a great sketch.
Do 4
Yeah, I could plug in another one.
for y.
If you plug in 4 for y, that gives you x squared equals 64, which means x would equal, yep, 8. So that's a little bit better. So we got 8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And right there. That's pretty good. And draw your parabola. Any questions on? No. Okay. All right. Let's try this one. It says find an equation of the parabola. The vertex is at the origin. The axis of symmetry is the x-axis. And the parabola contains the point -1/2, comma 2. So you have to understand what a parabola is and start thinking about these pieces of information and how they help you. So I've got the vertex, and I've got a point. What is it that I can't easily figure out directly from that information? Eventually I can get it, but they really haven't given me an easy way to find the what.
Focus.
They have not given me an easy way to find the focus. I need the focus. Right? That's important. All right. Axis of symmetry is the x-axis. Knowing that's the axis of symmetry, what does that tell me about the parabola? It tells me a little bit about it. Yeah? It has to open left or right. It's got to do one of those two things. It cannot open up or down. All right. If I know that it opens left or right, I can start to think about my equation a little bit. I don't know the number there yet. It's either a 4 or a -4. But I know that it opens horizontally. So what letter has to go over here? Yep. Horizontally, yeah. So that has to be an x. And what letter has to be over here? Yep.
Y squared.
Right. Remember, parabola is the only conic we study where one letter is squared and one letter isn't. Okay, so I got this far just from this fact. Now I need to use the bottom fact. It has to contain the point -1/2, 2. So which way is it going to open? Yep.
Well, I was going to say that also means that it will have the point -1/2, -2.
Yep, because there'll be symmetry, so there'll be another point down there somewhere. So this parabola has to open to the left, which means what number goes in that box? -4. Okay, so at least we know the equation we have to use. The problem is you don't know A. Okay, without A, you're not writing that equation. You've got to find A. How can I find A based on what they've given me? Well, what have they given me in relation to that equation? They've given me,
Can you plug in the points to solve for A?
yeah, they've given me an x and they've given me a y. So I can fill in the x and the y, solve for A, and then write the equation. So y is 2. A we don't know. -4, that's part of the equation. and x is negative a half. So let's simplify and solve for it. What's negative 4 times negative a half? Right? 2. So we get 4 equals 2a, which means a equals 2. All right. Now we know a is 2. We can fill that back in and write the equation. What's going to be on the right-hand side is simplified as possible. Yeah.
Negative 8x.
Negative 8x. There you go. So that's the equation of a parabola opening to the left that meets those conditions. So there's lots of different variations you can have on these problems in terms of like what information I give you to have you find the equation, or even if I give you the equation, what information I have you give me. Generally, when you're giving me information, those are the only things I would ask you right there. Okay, so any question on finding an equation, describing it, or graphing? Those are really the three things. Now, every parabola we've done so far has had the vertex at the origin. So what we want to look at now is what happens when it's not at the origin. Okay, they give you this whole table. This is well, it'll be in the video and it's in the textbook. But it's more important to just understand the pattern, and then you automatically will know everything in this table without really trying to memorize it. Okay. First thing that's going to be different is there's going to be 2 more letters in the equation, an H and a K. The H and the K are going to be the coordinates of the vertex. So now, when you are writing the equation of a parabola, there's going to be 3 things you have to find: H, K, and A. Those are the 3 things. Up until now, the H and the K have been 0 and 0. A is still exactly what it was before. A is the distance between the focus and the vertex. It's just the vertex isn't at the origin anymore. Okay. So all that I'm going to focus on is this part of the table right there. Because if you understand which way the parabola is opening and what A means, you don't need to memorize all these different formulas to figure out the focus and the directrix. You can just say, okay, it's opening to the right, so that means the other thing goes to the left. You can just kind of reason it out. Otherwise, it's a lot to try to memorize it all. Okay, so they all follow the basic pattern we had before. Something squared equals 4 times A times something. The difference is the X has a minus H with it. The X and the H always stay together. H tells you the left and right movement of the vertex, and the X is the axis that goes left and right. So that's why you keep X and H together. K tells you the up and the down movement of the parabola. Y is the axis that goes up and down. So you always keep the Y and the K together. So it's basically the same equations we just had. Just change your X to X minus H and change your Y to Y minus K. And it's the same 4 equations. And you shouldn't have to memorize these descriptions. You should be able to just look at that and say, okay, it's a Y, which means it opens up or down. There's a negative symbol right there. That means it opens down. There's a negative symbol, and there's an X. Negative X is to the left. You really don't need to memorize all that. Vertex is at HK. I wrote that right there, so you don't really need to write that again. And A, I wrote that earlier as well. A is the distance between the focus and the vertex. And as far as the questions, it's going to be just like the other ones. I can give you an equation, and I might say, describe it to me. Or I'll describe something to you, and you give me the equation. Or I say, here's an equation, graph it. Or here's a graph, tell me the equation. It's all the same kind of variations of questions. All right, so let's look at this one. So find an equation of the parabola that meets those conditions. First thing I do off to the side, if you can figure those three things out, you're going to be good. All right, so let's start with the vertex. The vertex tells me a lot of important information. Let's start with h. What's h in this problem? Yep. -2. What's k in this problem? Yep. 3, yeah. The vertex tells you h and k directly. The only thing we need now is a, which is the distance from the focus to the vertex. If you're more visual, then draw those 2 points and figure out the distance between them. -2, 3 is your vertex. 0, 3 is your focus. What's the distance between the vertex and the focus? Again, I don't think you need to make a sketch there, because 2 of the numbers are always going to be the same because they have to line up with each other. So you just have to find the distance between the other 2 numbers, really. Huh? 2. So now, I think what the sketch helps you with is to figure out your equation. Based on this sketch, which way does the parabola open? It can only open one way. Yeah, has to open to the right. It's going to wrap around the focus, and it's going to go right through the vertex. Okay. Parabola opening to the right. So we know we got it's going to be a 4 because it has to open to the right, and it's positive. And what letter are we going to put on this side so that it opens right? Yeah, x. And remember, now because we've shifted it, we just have to make it x minus h. And now that means on the other side, it normally would just be a y, but it's going to be y minus k squared. So that's the equation of a parabola opening to the right. And now we fill everything in, and that's it. So we're going to have y minus 3 equals 4 times a. It's going to give me 8. And what's going to be in parentheses when I do x minus h?
X minus h, or x minus -2, which is x plus 2.
Right, it's going to become a plus. So that's one thing you have to be careful when you are working backwards. If I gave you this equation and I said to you, describe this parabola to me, first thing you want to do is think of this as x minus minus 2. Otherwise, you're going to mess up your h. Well, that's it. That's your equation. Any question on that one? Okay, so I've kind of been saying this all along, but generally, when you have one letter that is quadratic or squared, and the other letter is linear. That's what makes it a parabola. Every other conic section that we study this week, both letters are going to be squared. The x and the y will be quadratic. All right, so let's try one of these in reverse of what we just did, and I think that will be it. Okay. In the video, there is something about completing the square. We're not going to do that part of this lesson. All right, so so discuss. That means I want you to tell me 4 things: vertex, focus, which way it opens, equation of the directrix. Let's do x plus 3 squared equals, I'll generally try to make this number a multiple of 4, because if I don't, it just makes the distances decimals. Okay. What are the 3 letters that we need to define here? Yeah?
HKA.
HKA. H, K, and A. Let's start with the X. What letter is always with X?
H.
H. Now we can't think of H, we can't think of it like this. We need to think of it like this. Otherwise you're going to mess up your H. So what's H in this case?
-3.
Right. It's always the number after the minus sign. X minus, that's H. What letter is always with the Y?
K.
K. And what's K in this case?
2.
2. Okay. We've got enough information, we can write the vertex now. What's the coordinate for my vertex?
12, -3.
What's the formula for the vertex? It's what comma what? Yep.
H,
H comma K.
H.
So in this case, the vertex would be
2, -3. No, -3 too.
-3, 2.
I'm not really good for it.
Okay, so we got our vertex. Next thing we should try to figure out is, let's see if we can get A. Okay. What's A in this case? Yeah. 3. You've got to think of it as 4 times A. Well, what would A be to get 12? 4 times 3. So now you know how far away the vertex is from the focus. But we don't know, should I go up 3 units, down 3 units, left 3, or right 3? It's one of those 4 from that point. Okay. Which way does this parabola open? Up, down, left, or right? Yeah? Up. +4 with a y. Y direction means vertical. Positive means up. Opens up. Now that we know it opens up and the vertex is there, the focus is 3 units up. What would be 3 units above the vertex? Yep.
0. No. It's 3, 5. -3, 5.
-3, 5. That coordinate is 3 units above the vertex. So we got vertex, focus, which way it opens, and directrix. Well, is the directrix going to be a horizontal line or a vertical line? It's going to be horizontal. And if the vertex was, if the focus was 3 units above, the directrix is still 3 units. It has to be 3, but it's not above, it's below. So what would be the horizontal line? 3 units below that. Yep.
-3, -1.
Well, we need an equation.
Y equals.
It's going to be the
Y is
line that
-1.
y equals -1. Yep. So the vertex has to be exactly halfway between focus and directrix. Excuse me. All right, any question on that one? All right, so that's pretty much all we're going to look at with parabolas. That's our first conic section. All right. So, I just have to change a couple. Okay, and a lot of them are matching. So there's a lot of matching in this section. You will notice too that this is from a different book. So when you look at the PDF online, I checked it, PDF for this section that I showed you on Schoology, it is correct. But it's from a different book, so I'll just keep that in mind. Yeah, it just looks a little different. Yeah, 11 through 18, that's all matching. 47, we're not going to do that one. 55, that one's okay. Okay, I think, yeah, the rest of that's okay. So that's 11 to 18, that part's matching, that's all. Everything else is odd. And we'll take a look at that first thing tomorrow.